Hello, grade 12. Welcome back to the channel. In today's lesson, we're going to be looking at probability and we are focusing on counting principles. So without any further ado, let's look at this question that we have here. So we have 11.2. It says 6 players of a volleyball team stand at random positions in a row before the game begins. X and Y are 2 players in this team. Then they say determine the probability that X and Y will not stand next to each other. Now, with this type of questions here, you need to consider that we can solve this question using the fact that we know about complementary events. So if we have the probability of A, add that to the probability of not A, we know that we should get 1, right? So to find the probability that X and Y will not stand next to each other could be a pretty daunting task. So the way in which we're going to approach this question is to say, let's calculate the probability that X and Y will stand next to each other. So we'll be looking at all the possibilities that X and Y will stand next to each other. So this is probability of X and Y next to each other. So next to each other. Okay, so if we are looking for the probability of X and Y being next to each other, we know that we have 6 players, but then remember that X and Y can be next to either in 2 factorial ways. That is to say, in 2 different ways, right? So this could be X and Y standing next to each other in this fashion, or they could be standing to each other in this fashion, YX. So we say that 2 factorial ways in which we can make X and Y stand next to each other. But then these are questions whereby we have to take X and Y as an item or 1 unit. So we then say if we are taking X and Y as 1 unit, then that means the positions in which we have to fill there are 5 positions instead of 6, right? Because remember, in every kind of way, the X and Y always have to be next to each other. So we have 1, 2, 3, 4, and then 5 positions to fill. So whereby 1 position can be filled by X and Y at a time, right? So we are taking them as an item. So take X and Y as if it's 1 person, right? Then if we are taking X and Y as 1 unit, that means we have 5 places to fill. So the first position here, in how many ways can we fill that position? We can fill that position in 5 different ways, right? So by placing 5 different one of the 5 different players, and then we can fill in once 1 player there is standing in that position. That means no player can stand in that position again. So we are left with 4 positions to fill. So we have 4. And then once another player is standing in that position, now we are left with 3 positions. So we fill 3 here. And then once 3 are standing, then we are only left with 2 positions. So we can put in 1 here, and then we put another 1 in there. So there are 5 factorial ways in which these 6 players can be seated, given that X and Y are taken as a unit. So 5 factorial, but then we have to multiply it by 2 factorial for the fact that we are taking X and Y as a unit and they can be seated in 2 factorial ways. That is to say, they can be standing as XY or YX. So that's the 2 factorial part. Now, if we have 5 factorial multiplied by 2 factorial, punching in your calculator, that is supposed to give you, so let's punch 5 factorial multiplied by 2 factorial. That is supposed to give us a 240 factorial, right? So that's 240. But then if we are to write this as a probability, we want the probability that X and Y will stand next to each other. So now let's have our sample space. Our sample space, remember, this is the maximum number of arrangements that we can have without any restrictions. So if we had no restrictions at all, the number of arrangements that we could have there are 6 factorial, since we have 6 players and then we must place them in 6 different different positions. So that's 6 factorial, and then that's going to give us 6 factorial, that's 720. So there's 720 arrangements that we can make from those players. Then as a probability, we can write that as 240 over 720. But then remember, this is the probability that X and Y will stand next to each other. What are we looking for here? We are not looking for the probability of X and Y standing next to each other, but we are looking for the probability of X and Y not standing next to each other. So now we're going to say probability of X and of not X and Y. So of not X and Y standing next to each other. So is what? 1 minus the probability of X and Y standing next to each other. So now that we have the probability of X and Y standing next to each other, to calculate the probability of them not standing next to each other, it's 1 minus 240 over 720, right? Or you can just say 1 minus 5 factorial multiplied by 2 factorial over 6 factorial. Now, again, punching that in your calculator, you have 1 minus 240 over 720. That's going to give us 2 over 3, right? So just like that, you have your probability of X and Y not standing next to each other. So whenever you are given a question that says not, always put it in the back of your mind that you must use complementary events, right? Then, okay, let's proceed. We have 11.3 there. So 11.3 says determine how many 4-digit numbers can be formed from 10 digits, which are from 0 to 9, if repetition of digits is allowed. So we are required to form a 4-digit number. So 4-digit number. There we go. And then they're saying the repetition of digits is allowed. So that means if I use a particular digit in the first position, it does not restrict me from using that same digit in the other positions. So repetition is allowed. So that means in how many different ways can we fill in the first position is 10, because we can put any number from those 10 digits. And then in the second position, because repetition is allowed, my sample space is still 10, right? So I can still choose from the 10 digits that are available. And then in the third position also 10, in the fourth position also 10. So we have 10 to the exponent of 4. That means we can have how many digits? 10,000 digits, right? So these are the maximum number of digits that can be formed if repetition is allowed. Now, what if repetition is not allowed? Again, we must form a 4-digit number. So when I have 4 positions, 1, 2, 3, 4, right? So, but then in the first position, I can choose one of the 10 digits that are available. But then remember, if they say repetition is not allowed, that means if I happen to pick a certain digit in the first position, I can no longer pick it for the second position. That affects my sample space. So in the second position, I have to choose from the 9 digits that will now be available. But now if I already have 2 digits in place, that means I can no longer choose from those digits that I've placed there. I have 8 digits to choose from. So it affects the sample space. And then of course, in the fourth position, I will have 7 digits to choose from. Then to get the total number of digits or numbers that can be formed is to say 10 times 9 times 8 times 7. Then you just grab your calculator, 10 times 9 times 8 times 7. Then that gives you 5,040 digits, right? So we can have 5,040 digits if we do not repeat the digits. Now, 11.3.3 says the condition is that the last digit must be 0 and repetition of digit is allowed. So repetition of digits is allowed, but then the only restriction here is on the last digit. The last digit must be 0. So there is only, now this is the last digit. There is only one way in which we can put a 0 there because we only have 1 0. So that's 1. So we can only choose from one number, right? And then what about the other positions? In the first position, because a repetition is allowed, we can put in 10. Because remember, by repetition is allowed, that's saying that even if you decide to put that 0 here at the end, it does not really restrict you from putting it in the other positions. Remember, they did not say the last digit must be the only one that is 0. Or they did not say 0 must be used as the last digit only. Yes. So they said repetition is allowed. That means if you have a 0 here, you can also put 0 in other positions. Then that's 10, 10, and then 10. So that's 10 to the exponent of 3 multiplied by 1, which will give us 1,000. So you can see that the more we put in the conditions, the less the number of numbers we can form, or the less number of codes that we can form. Yeah, whatever. Now, 11.3 says 4 different economic books and 3 different life science books are required to be placed on a shelf. 11.3.1 says if you decide to place any book in any position, in how many different ways can you arrange the books on the shelf, right? So for this one, you just have to count how many books are there. So in total, so we have 4 different economic books and 3 different life science books. All in all, we have 4 plus 3, so that's 7 books. So we know that if you place a certain book, you cannot place it again. So with the books here, obviously there wouldn't be any repetition. So that's just 7 factorial. Then you just punch in your 7 factorial, see what it gives you. So for 7 factorial, we have 5,040. So there is no way you can repeat books. Then 11.3.2 says if 2 particular books must be placed next to each other, in how many different ways can you arrange the books on the shelf? Now they're saying if 2 particular books, so certain books here need to be placed next to each other. So if we name those books, let's say we name the books book A and book B, right? So we know that there are 2 factorial ways in which those books can be next to each other. Can be in the form of AB or BA. So in total, we have 2 factorial ways in which we can place 2 particular books next to each other. Now, what are we going to do? We're going to take those 2 books as a unit, as one item. Now, remember, we have 7 different books, right? But then if we are taking those 2 books in particular as a unit, that means now we are left with 6 positions. So we must fill in 6 positions. That's 1, 2, 3, 4, 5, 6, right? So we are taking particular book A and particular book B as a unit, right? So that means we can fill the positions here in 6 factorial ways. So that's 6, 5, 4, 3, 2, 1. So we're going to have the 6 factorial, but multiply that by the 2 factorial. The 2 factorial from saying that we can place the books as AB or BA. Now multiplying that, we have 6 factorial times 2 factorial. That is going to give us 1,440 ways. Okay, ways. Now, 11.3.3 says if all economic books must be placed next to one another and all the life science books must be placed next to one another, in how many different ways can you arrange the books on the shelf, right? So now they're saying the economics books must be next to each other and also the life science books must be next to each other. So we have 1, 2, 3, 4, right, for the economic books. And then we have 1, 2, 3 for the life science books. So to place the economic books, there are 4, so we can place them in 4 factorial ways. So that's 4, 3, 2, 1. But with the life science books, there are 3. We can place them in 3 factorial ways. That's 3, 2, 1. Right. But then remember, there is no condition as to the economic books must be the first books to be placed and then the life science books. They did not put in that restriction. So that means we know that there are 2 factorial ways in which we can have this. We can either have the economic books being the ones that are placed first and then the life science books, or we can have the life science books first and then the economic books. So to include that point is to say 2 factorial, right? To also consider the part that we can have economics, then life science books, or life science books first, then economic books. So we're going to say multiply by 2 factorial. So what do we have here? That's 4 factorial multiplied by 3 factorial, meant to say, then multiply again by 2 factorial for the fact that we can have economics, life science, or life science economics. Then 4 factorial multiplied by 3 factorial multiplied by 2 factorial. Then that's going to give us 288 ways. Okay. Then yeah. Let's proceed. Okay. 11.2 says consider the word spectrum. In how many ways can the 8 letters be arranged? So if we are just arranging them in any order, then that means in how many different ways can we arrange that? Obviously, this is assuming that there are no repetition of letters, because this is just arrangements, right? Remember, we are not trying to form other words using the letters for spectrum. We are just arranging them. So we can arrange them in 8 factorial ways, because spectrum is an 8-letter word. So 8 factorial, that's supposed to give us a 40,000, meant to say 40,320. Then B, such that the first letter is a vowel. Now we're gonna be looking at this word spectrum, and then observing this word, we can see that we only have 2 vowels here. So that's the E and the U. Remember, vowels are A, E, O, U, right? So from the word spectrum, the only vowels that are present are E and U, right? So 1, 2, 3, 4, 5, 6, 7, 8. Then we can have that. And then such that the first letter is a vowel. If the first letter needs to be a vowel, that means we can fill this position in 2 different ways, right? So we can either put an E there or a U, right? So that 2, there's a sample space of 2 for the first position. So either an E or a U, right? And then we can fill in the rest of the positions in 7 factorial ways. So that's 7, 6, 5, 4, 3, 2, 1, right? So that's supposed to be 2 multiplied by 7 factorial, right? So yes, and then that's supposed to give us 2 times 7 factorial, and then that's a 10,080 arrangements, right? So note that the 2 here doesn't necessarily mean that we are filling this in 2 factorial ways. This means that we can either put an E or a U there. So there are 2 letters that can go in there, right? I hope it makes sense. There are 2 letters that can go in there, either an E or a U. Then 11.2.2 says calculate the probability that in a particular arrangement of the 8 letters, the letter T, P, R will be next to each other in any order. So now it is required that TPR should always be next to each other. So that's TPR should always be next to each other. Right. Now, we know that in any order, so that means TPR must always be next to each other, but then not in the form TPR only. It can be in this way, that's TPR, can also be as TRP, right? And then can be PTR, or can be PRT, right? Or it could be RTP and then RPT, right? So this is in any order. That means to arrange these three letters TPR in any particular order, this would be 3 factorial. 3 factorial means that we're going to have 6 possible ways. As you can see from here, these are 6 possible ways. So we're going to say 3 factorial for this TPR. And then what are we going to say if we are taking TPR as 1 unit, right? If we are taking them as 1 unit, that means how many positions do we now have to fill? So that's 8 minus 3. That's going to be 5, but then plus 1, we're going to have 6, right? So why plus 1? Because there are now 6 positions that need to be filled if we are taking TPR as 1 unit, right? So that means we can fill it in what? In 6 factorial ways. We can fill in the positions in 6 factorial ways. But then that 6 factorial, multiply it with what? With the 3 factorial that we have here. So if we are saying 6 factorial multiplied by 3 factorial, that will give us 4,320. But then remember, we are writing this as a probability, right? So as a probability, we must say probability of that event is equals to the number of the event over the number of the sample space, right? So the number of the event is the 4,320. But then what is the sample space? The sample space is the one that does not include any restriction. So the one that does not include any restriction is the 40,320 here. So if we say 4,320 divided by 40,320, that will give us 3/28. And then this becomes our probability for 11.2.2. Right. Hope it makes sense. Okay, then we have question 13 says, Cindy has the following books to arrange on a shelf. There are 4 mathematics books, 3 physical science books, 2 life science books. Now they say determine the number of different ways that all the books can be arranged. Now if they say determine the number of ways in which all the books can be arranged, we just add the books here. How many books do you have? 4 plus 3, that's 7, plus 2, that's 9. So that means you can have it in 9 factorial ways, right? So you can arrange in 9 factorial ways, which gives us 362,880, right? And then 11.2 says determine the number of different ways that the books can be arranged in order that the books in each learning area are next to each other, right? So, okay, now we must arrange the books in such a way that the learning areas are next to each other. What can we say about that? Now, if we are to arrange the mathematic books, we know that we can arrange them in what? In 4 factorial ways, right? Then if we are to arrange the physical science books, we can arrange them in 3 factorial ways. And then if we are to arrange the life science books, we can arrange them in 2 factorial ways. But then remember, this is maths, physical science, and then life sciences. Now you can also have 3 factorial ways in which you can mix up these books, right? So you can either have maths book, then physics books, then life science books, or maths books, life science books, then physical science books. Or you can have physical science, maths, then life science, or physical science, life science, then maths. Or you can have life science, maths, then physics, or life science, then physics, then maths, right? So in total, these are what? 3 factorial ways. So to answer that one, we are going to say, okay, the number of different ways in which we can do this is to say 4 factorial for the maths books, then multiplied by 3 factorial for physics, then multiplied by 2 factorial for life sciences, then but multiply all that by 3 factorial, because there are 6 different ways in which you can mix up the books, right? So 4 factorial multiplied by 3 factorial multiplied by 2 factorial multiplied by the 3 factorial. So the 3 factorial is representing all the 6 possibilities. Then that will give us 1,728 ways. Now, 13.3 says, in how many different ways can all the books be arranged in order of descending height? So if they must be in the order of descending height, that means it is just as simple as that. You just go. So descending height means from the biggest to the smallest. So from the one that has a large number to the one that has a smaller number. So already here we can see that this is in descending order. So you would put the maths books first, then followed by the physical science books, then lastly the life science books. So the condition is just like that. And then you just go 4 factorial multiplied by 3 factorial multiplied by 2 factorial. So your solution there would just be 288 ways. And then done. Okay, then we have question 10. It says, in a certain country, 10-digit telephone numbers with the following format were introduced. So we have a format which says, number of digits. The area code must consist of 3 digits. The exchange code must consist of 3 digits, and then the number must consist of 4 digits. So all in all, that's 10 digits. Then an example, they gave us an example. The number can be 901, 544 here, and then 1230 there. Now they're saying how many possible 10-digit telephone numbers could be formed if digits may be repeated. Now we must form 10-digit code. So if digits can be repeated, that means in all these positions, we can fill in one of the 10 digits. So that's 10 to the exponent of 10, right? So yeah, which will give us that. I won't write all the answer there, but then that's supposed to be 1 and 10 zeros. And then certain restrictions were placed on the group of digits, and then area code must be 3 digits, and the first digit cannot be 0. So these are the restrictions that they place. They say the area code must be 3 digits and the first digit cannot be 0. Yes. Then exchange code must be 3 digits and the first and second digit cannot be 0 or 1. Right. So also here the area code, the first digit cannot be 0 or 1. Then the number must be 4 digits and the first digit must be, so here it must be a 0 or 1. Okay. So let's have a look at this question then. So if 10.2.1 says how many valid 10-digit telephone numbers could be formed by applying the given restriction. So if we are to do this, we are supposed to form 10 digits from this format: 1, 2, 3, representing the area code, 1, 2, 3, representing the exchange code, then 1, 2, 3, 4, representing the number. Right. So now they say the here how many valid 10-digit telephone numbers could be formed by applying the given restrictions, right? And then remember, digits may be repeated in this case. Then if we are to fill in the position here, remember 0 or 1 must not be included. That leaves us with a sample space of 8 from the 10 digits. Remember, from the 10 digits, we are now excluding the 0 or 1. So that leaves us with 8. But then for the area code, the restriction is only on the first digit. That means for the 2 digits that are following the area code, it can be any number from 0 up until 9. So we have a sample space of 10. Also here we have a sample space of 10. Now we are on the exchange code. For the exchange code, they say it must be 3-digit and the first and second digit cannot be 0 or 1. So if the first and second digit cannot be 0 or 1, that leaves us with a sample space of 8. But then remember, digits may be repeated. So that means having to choose a particular digit here does not necessarily restrict me from choosing the same digit in the second position, right? So, but in the second position, remember, the second digit cannot be 0 or 1. So this still leaves us with a sample space of 8. We can only choose from 8 digits, excluding 0 and 1. Then on the third digit of the exchange code, there is no restriction, meaning we can choose from the 10 that are available. Okay. Now, in the number must be 4-digit and the first digit must be a 0 or 1. So the first digit must be a 0 or 1. So that means we have a sample space of 2 here because we can either fill in a 0 or a 1 in the first digit. So the rest of the numbers are not allowed to go in here. It's only a 0 or 1. Then no restriction for the 3 following digits, right? So that means we can have a sample space of 10, 10, 10. So we can choose any number from the 10 digits that are available. Then to get your answer here, you simply just need to multiply everything there. So that's 8 multiplied by 10 multiplied by 10 multiplied by 8 multiplied by 8 multiplied by 10 multiplied by 2 multiplied by 10 multiplied by 10 multiplied by 10. So that gives us so that's 1024. So let's just write it in scientific. It's a very big number. So that's gonna give us scientific form, that's 1.024 times 10 to the exponent of 9, right? So we can just leave it like that. And then 10.2.2 says, determine the probability that any randomly chosen 10-digit number would be a valid phone number. So now we are determining the probability. So we know for probability, once again, probability of an event is the number of an event over the number of the sample space, right? So the number there, the number of possible digits of valid phone numbers are 1.024 times 10 to the exponent of 9, right? Over what? The sample space. So the sample space is the one without any restrictions, which is the 10 to the exponent of 10. Then if we do that, let's punch it in our calculator, 1.024 times 10 to the exponent of 9 over 10 to the exponent of 10. So that gives us 64 over 625, which if you can just SD that, that's 1.024 times 10 to the exponent of -1 in scientific form, right? So that's the probability of having to randomly choose any number that would be a valid number from the given sample space, right? And with all that being said, this is where we're going to cut our lesson. So just keep on practicing, guys, keep on practicing. And then, you know, with more practice, more question papers, the less anxiety that you have for your exams. Good luck.